everyone. We're going to work on Unit 7 and 8 review together. First question is asking us to find the degree and the leading coefficient. This polynomial is given. Degree of the polynomial is the exponent of the term which has the highest power. So here 8 is the highest power of all these 4 terms, so degree is 8. Leading term is the term that includes this highest power, so it's 5x to the power of 8. And leading coefficient is coefficient of x for this term, so it's 5. Next question is given a polynomial and it's asking us to find the end behavior. That means when n, or in other way x value, goes to positive infinity or negative infinity, what is happening to the function f, or basically to the y value of the function. So we're going to look at the polynomial. The degree of this polynomial is 6 because this is the highest power. So I'm going to write degree is 6. And the leading coefficient, for short, I just write LC, is equal to -3. It's just the coefficient of the term here. Now, the degree, as you see, is an even degree, and the leading coefficient is a negative value. And we know this is going to remind us negative x to the power of 2 that looks like a parabola that goes downward. So the end behavior of this function will be similar to this one. That means on both sides, when x goes to negative infinity, f of x, or basically f of n, is going to downside, which is negative infinity. So it goes to negative infinity. And the other side is also the same way like this one, goes to negative infinity. So when n goes to infinity, f of n goes to negative infinity. Next question is asking us to find the root of this function. This is easy to find the roots because the function is already in the factored form. So all you need to do is set each factor equal to 0, r minus 2 equal to 0, and solve for r. So here r is equal to 7, r equal to -1, and r equal to 2. So these are the roots of the function. The multiplicities are the power of the factor which created each root. So for 7, the power of the factor that created root 7 was 8. So that's the multiplicity of the first one. The second one is 9. And third one is 1. If you don't see anything, it's basically 1. So these are the multiplicities of the factors. Next question is asking us to find the x and y intercept of this function. We know that x-intercept is basically, y-intercept. I'm going to work on this one first. Y-intercept is when your graph is crossing the y-axis somewhere like this point. At this point, x is equal to 0. So in order to find the y value of this point, all I need to do is set the x equal to 0 and plug into the equation. So the y value will be 0 times 0 minus 2 times 0 plus 8. Well, this is -2, this is 8, but anyway, 0 times any number is equal to 0. So the y-intercept is at 0. Then what is the x-intercept? The x-intercept is where the graph is crossing the x-axis. At this point, y is equal to 0. So we're going to set this whole equation equal to 0 and solve for x. Since this is already in the factored form, it's easy to solve. You just need to set each factor equal to 0. First one is x equal to 0. This is already giving us the 0. Then x minus 2 equal to 0. That means x is equal to 2. And x plus 2 equal to 0. That means x is equal to -2. Oh, sorry, this was 8, not 2. So I'm going to change it 8, and this is -8. So the zeros are 0, 2, and -8, which are also called x-intercepts. Now, again, it's asking us for the end behavior of the function. To find the end behavior, you need to know the degree of the function. What is the degree of this function? If your function is in factored form, in order to find a degree, you need to find the degree of each factor and then add them all together. So degree of x is just 1. Degree of x minus 2 is also 1 because degree of x is 1, degree of the parenthesis, the whole factor is also 1, and 1 to the power 1 is 1. And degree of the next one, which is 8 plus 8, that is also 1 because degree of x is 1, degree of the power of the factor is also 1, and 1 to the power 1 is 1. Now the whole degree will be, you're going to add them all together. It's going to be 1 plus 1 plus 1, which is 3. So one more time, I'm going to explain. If your function is in the factored form, you just need to add the power of each factor, add them all together. That's going to be the degree of your function. Okay, so degree of this function is 3. And what is the leading coefficient? Again, for leading coefficient, you need to find leading coefficient of each factor. And this time, you're going to add them all together. Okay, so the factors are x, x minus 2, and x plus 8. Leading coefficient of x is 1. Leading coefficient of x minus 2 is 1. And since the power is also 1, 1 to the power 1 is 1. X plus 8, the leading coefficient is 1. And the power is also 1. 1 to the power 1 is 1. And this time, you're going to multiply them. You're not going to add them. So 1 times 1 times 1 is equal to 1. So generally, we can say the degree is 3 and leading coefficient is 1. So we have a degree which is odd and leading coefficient is positive. So this is going to remind us x to the power of 3. That means the function should look like something like this. This should be the general form of the polynomial. Now, what is the end behavior? That means when x is going to infinity, y is also going to infinity. Goes to the positive side, y is increasing. And when x goes to negative infinity, y is going down. So goes to negative infinity. Now we want to find what is the graph of the function. Obviously, this is not the function because we have 3 zeros. This is passing through this point, and this point has only 2 zeros. So this is not the function. And the same is also this one because they have only 2 zeros, but our function should have 3. Now let me go to next page. That's my other graph. And as you see, these two have 3 zeros. This one has a 0 at -8, 1 at 0, and 1 at 2. This one also -8, 0, and 2. So they both could be my candidates for this question. However, this one will be the answer because we decided that when x goes to infinity, y goes to positive infinity. When x goes to negative infinity, y goes to negative infinity. That means the graph should look like this. And this is the one that tells me the function could be this way because it like goes up, down, and then goes up again. Question number 5 is asking us to do the division using long division. So I'm going to write x minus 1 here and x to the power 4 minus x to the 3 minus 4x squared plus 3x plus 1. And let's do the division now. Divide first term by first term. X to the 4 divided by x is x to the power of 3. Then multiply x to the 3 by x, which is x to 4, and x to the 3 by -1, that's negative x to the 3. Then we're going to subtract them. X to the 4 minus x to 4, they cancel each other. X to the negative x to the 3 minus negative x to the 3, they also cancel each other. So now I'm going to bring this one down. Next term, negative 4x squared. Divide this by the first term. Negative 4x squared divided by x will be negative 4x. So I'm going to write that here. Now, negative 4x times x will be negative 4x squared. Negative 4x times negative 1 will be positive 4x. Now I can bring the other one down as well because I already have a 4x here, so I can combine them together. Now subtract. Negative 4x squared minus negative 4x squared cancel. 3x minus 4x will be negative x. Now I'll bring the next one down. Now divide first term by the first term. Negative x divided by negative x is negative 1. Negative 1 times x is negative x. Negative 1 times negative 1 is plus 1. Now subtract them. This times minus itself is 0. 1 minus 1 is also 0. So the remainder is 0, and the quotient will be x to the 3 minus 4x minus 1. Next question is asking us to use a synthetic division to divide this polynomial by x plus 2. So the first thing that I'm going to do is set x plus 2 equal to 0 and solve for x. That means x is equal to negative 2. I'm going to write negative 2 here and put it in a little box here. Then list all the coefficients over here, coefficient of all the terms. Make sure there's nothing missing here. We have x to the 3 and 2 and then 1 and then x to the power 0 here. So nothing is missing. So I can just list all the coefficients, 9, 18, and 13. Then you're going to bring 1 down. 1 times negative 2 is negative 2. 9 plus negative 2 is 7. 7 times negative 2 is negative 14. 18 plus negative 14 is 4. 4 times negative 2 is negative 8. And 13 plus negative 8 is 5. Now, the last number here is your remainder. And what you see here, these are the coefficients of the quotient. That means this is a constant term. Next one is x to the power of 1. And next is x to the power of 2. So your quotient will be 1 times x squared, which is just x squared. 7 times x to the power of 1, that's 7x, plus the constant term. So that's the quotient, and the remainder is r. Next question is asking us to find the factored form of the polynomial, which the zeros are given all here. So we have 1, 2, 3, and 4 zeros. So if one of the zeros is x minus 1, I'm sorry, I'm going to write that again. One of the zeros is x equals to negative 1. Then the factor that created this is x plus 1, because I'm going to move the 1 to the left side. So it's going to be x plus 1 equal to 0. So this is the factor that created negative 1. So I'm going to write x plus 1. That's one of the zeros. The other one, x equal to negative 2. So move negative 2 to the other side. So x plus 2 is the factor that created the next one. So x plus 2. And then 3. X equal to 3 is the 0. The factor that created that was x minus 3. So write x minus 3. And the last one is x equal to 1. Subtract 1 from both sides, and x minus 1 equal to 0. This is the factor that created this 0. So this is the polynomial that we were looking for. Okay, let's look at the next question. Find the degree 3 polynomial with real coefficients that have zeros that are 2 and 3. So one of the zeros is 2. So the factor that created the 0 is x minus 2. You already know that. The other 0 is x equal to 3i. So if I move 3i to the left side, it's going to be x minus 3i. Notice that we have basically the degree of the function as 2 so far, because this one is 1, the other factor is also 1. When you add, then the degree is 2 so far, but it should be degree 3. That means we're missing another factor. What is the other one? Notice that if we have a 0, which is a complex number or imaginary number, then the conjugate of that will be also a 0 of the function. What is conjugate of 3i? 3i is equal to negative 3i. Let me just give you a side note here. If you have a complex number as a plus bi, then the conjugate of that is a minus bi. So here, if I have 3i, the conjugate of that will be negative 3i. So the term that has I will be negative. Anyway, so I know if I have 3i as a 0, negative 3i is also a 0 of my function. So the factor that created this will be x plus 3i, because I move the 3i to the left side. So I add 3i to the both sides. So it's going to be x plus 3i equal to 0. So that's how I know this is my other factor. So these are the factors of the function. But then we need to write the polynomial in the expanded form. Okay, so this is my polynomial. I'm going to expand all these factors so I can find the equation in this form. Okay, I'm going to start with this one first. Expand these to x times x is x squared. X times 3i is 3i times x. Then negative 3i times x. And then we have negative 3 times 3 is 9, and I times I is I squared. 3ix and negative 3ix cancel each other. So I will have x squared here. On the other hand, we know that I squared is equal to negative 1. So if this is negative 1 times negative 9 makes it positive 9. And I had another factor, x minus 2, and we're going to distribute those as well and expand them. X times x squared is x to the 3 times 9 is 9x. Negative 2 times x squared is negative 2x squared. And negative 2 times 9 is negative 18. So we can put them all in order and write them as this way. Next question is asking us to use the rational zero theorem to find all possible zeros of the function. So in order to do that, you need to find the factors of the constant term, which is 21. So you're going to write that here on top, and factors of the leading coefficient, which is 1. And we're going to divide them. Factors of 21 are 1, 3, 7, and 21. Factors of 1 are only 1. Then you need to consider all positive and negative of both of them. So the zeros will be 1 divided by 1, 3 divided by 1, 7 divided by 1, and 21 divided by 1. But we need to consider positive and negative of all those cases. And here's the list of all of those. Okay, so next question is asking us to find the factored form of this polynomial, knowing that x equal to 1 is a 0 of the function. Use the factor theorem. What does factor theorem mean? That means if you have a 0 of a function, if x equal to 1 is a 0 of the function, then I'm going to subtract 1 from both sides, and x minus 1, obviously, as we have done before, will be a factor of my function. So this is what it's saying. Now I need to find the other factors of the function. I already found one. How do I find the other one? This is what you're going to do. You can use synthetic division here. Put the 1 here and list the coefficient of the function here. 1, 4, 1, and -6, and then divide that by x minus 1, basically. So 1 bring down is 1. 1 times 1 is 1. Plus 4 is 5. Times 1 is 5. 1 plus 5 is 6. 6 times 1 is 6. -6 plus 6 is 0. And this is going to prove that, yes, we were right. This x minus 1 was a factor of the function, and as a result, x equal to 1 is the 0 of the function, because this is the remainder. Anyway, now how do I find the rest of the function? What is the other factor of the function? As we know, this quotient is equal to x squared plus 5x plus 6. This is the quotient of the function, but at the same time, it's the other factor of the function. So I can write that here as the other factor. Now I'm going to see if I'm able to factor this one more step or not. Can I find two numbers that add up to 5 and multiply to 6? Yes. Those two numbers are 2 and 3. So I can factor this as x plus 2 and x plus 3. Notice that I can do this because the coefficient is 1. Otherwise, I had to split the middle term using these two. But now I can use the shortcut and just write x plus 2 and x plus 3. And the other factor was already x minus 1. Okay, for this question, we want to factor the polynomial. As you see, I cannot easily factor this. I cannot put them in groups and factor using the grouping method. So what I can do here is just use the method that we did before, factors of the constant term, which is -2, and find factors of the leading coefficient. What are those two? Factors of 2 is 1 and 2. Factors of 12 are 1, 2, 3, 4, 6, and 12. So what are the possible zeros of the function? You're going to divide everything from top by the bottom. So 1 by 1 is 1, 1 divided by 2, 1 divided by 3, 1 by 4, 1 by 6, and 1 by 12, and then 2. 2 divided by 1, 2 divided by 2, 2 divided by 3, by 4, by 6, and by 12. I know that some of them are repeated. For example, 2 by 2 is repeated. So I can cross that. 2 by 4 is basically 1 over 2, so it's repeated. 2 by 6 is 1 over 3, which is also already here. And 2 by 12 is 1 over 6, that is also repeated. So positive and negative of the remaining numbers are the possible zeros of the function. But out of all these possible zeros, which ones are really a zero of the function? This is what I need to do. I have to divide the function by the factors created each of them and try them one by one and see which one matches. The easiest way to do that is use the synthetic division. So I'm going to try 1 and divide the function using synthetic division, -1, -9, and -2. If the remainder is 0, then that means 1 is a 0 of the function, and as a result, x minus 1 is a factor of the function. So let's try and see if this is a 0 of a function or not. So I'm going to bring 12 down. 12 times 1 is 12, plus -1 is 11, times 1 is 11, plus -9 is 2. 2 times 1 is 2, plus -2 is 0. So we were lucky that the first number that we tried gives us the 0 of the function. This is your remainder, and the quotient will be 12x squared plus 11x plus 2, because we know that this number is the constant term. This is coefficient of x. This one is coefficient of x to the power of 2. Anyway, so this is my other factor. I'm going to write the factors here for you. The first one that we found was x minus 1. And the second one is 12x squared minus 11x, plus 11x plus 2. Now, am I able to factor this one more step? Let's see. I'm going to erase this so we have some space here. How do I factor this? I'm going to look for two numbers that if I add them, I get 11. And if I multiply, I get 2 times 12, which is 24. What are those two numbers? They are 3 and 8. Now, since the a value is not 1, I cannot just write x plus 3x plus 8. I have to split the middle term. So this will be 12x squared plus 3x plus 8x. So I use these two to split the middle term plus 2. Now I'm going to put them in groups. The first group, they have 3x in common. So this will be 4x plus 1 when I factor 3x out. Second group, they have 2 in common. So when I factor 2 out of this one, I will have 4x left, and this one I have 1 left. Now, 4x plus 1 is the common term. You factor this out, and from the first one, you're going to have 3x left. The second one, you have 2 left. And the first factor was x minus 1 already. So this is the factored form of my polynomial. Question number 12, we want to find the zero of the function. Let's see if we can factor this polynomial or not. This is easy to factor because if I put them in group, I see that in the first group, they have x to the 2 in common. So I'm going to factor x squared out from the first two terms, and I will have this divided by x squared is x, this one divided by x squared is 3. And the second one, it's just x plus 3. They don't have anything in common. I need to fix this. X plus 3. I can say they don't have anything in common other than 1. So I'm going to write that here. Now, if I factor x plus 3 out, the first group I have x squared, the second group I have 1. So these are the factored form of the function. Now I'm going to find the zeros because I cannot factor this anymore. To find the zeros, we're going to set each factor equal to 0. So x plus 3 equal to 0. You subtract 3 from both sides, and x is equal to negative 3. This is one of the zeros of the function. This one, x squared plus 1 equal to 0. Subtract 1 from both sides, and x squared equal to negative 1. Then you need to take the square root of both sides. So x will be positive square root of negative 1 and negative square root of negative 1. And we already know about this imaginary number. I is equal to square root of negative 1. We have learned before I squared is equal to negative 1, and I will be square root of negative 1. So I can just write I instead of this, x equal to I and x equal to negative I. So these are the other zeros of the function, and we'll list them here. The next question is asking us to graph this radical function. First of all, I know that the parent function is y equal to square root of x, and it looks like this. This is the parent function of x, square root of x. Now, what transformations do we see? We have x plus 2. That means it has been moved left 2. And we have x minus 3. Square root of x plus 2 minus 3, a number is subtracted by the function. It's outside of the function. So this is going to move the function down 3. So this first point of the function, which is called the vertex of the function, will be moved 2 to the left and 3 down. As you see here, you move 2 to the left and 3 down. This is the first point of the function. What is the next point? If I consider the parent function, when x is equal to 1, the square root of 1 is also 1. So that's the other point of the function. this will also be moved to 2 to the left and 3 down. So from 1 and 1 here goes 1, 2 to the left and 1, 2, 3 down. So these are the 2 points, and then you can graph them using this pattern. The domain of the function, you're going to move from left to the right and look for the x values. The function starts from -2, and -2 is included, so you put bracket, and -2 to infinity is your domain. And now this function, you see x is subtracted by 2. That means the function is moved right 2, and then added 1. This is going to move the function up 1. So again, the parent function, which was kind of this form, the vertex will be moved right 2 up 1. So from this point, 0 and 0 are going to go 2 to the right, up 1. And the other point, which was here at 1 and 1, will be moved 2 to the right and up 1. And this is my function. The domain this time will be from 2 to infinity, because when you go from left to the right, it's starting from 2 and then goes to infinity. For next question, it's asking us to graph 6 to the power of x minus 4 and find the domain and range of this function. So I know the parent function is 6 to the power of x. This is the parent function, and it's going to look like this. When x is equal to 0, y will be 6 to the power of 0, which is 1. And when x is equal to 1, y will be 6 to the power of 1, which is 6. So one point is 0 and 1. The other one is 1 and 6, which is here. So the graph will look like this. This is the parent function. Okay, I mean, I cannot draw very well here, but it's some sort of this form, and there is a horizontal asymptote at x equal to 0. So this is a little bit better than the previous graph. Now, what is happening to my function? I have 6 to the x minus 4. That means the function is moved down 6. So the first thing that is happening is the horizontal asymptote, which was at 0, is going to move down 6 units. I'm sorry, 4 units. Minus 4 means down 4. So here at y equal to -4 is my horizontal asymptote. And those 2 points, 0 and 1, will be also moved down 4 points. So it's going to be here. And 1 and 6, which was here, will be moved down 4 points here. So now this will be the graph of my function. I'm going to erase everything else so you can see this better. So this is 1 point, this is the other one, and the graph, and here is the asymptote. Now, what is the domain? As I move from left to the right, I see that the function is covering everything, because even here, this part, this is going to continue forever and cover all the x values. So that's the domain and range from bottom to top. You see that we're starting from -4, but here's the asymptote, so I'm not going to include that. So I put parentheses to infinity. For next question, this time we see that the function is moved up 4 because I have 6 to the x plus 4. So again, the same way, the function, the parent function was 6 to the power of x, which the points were here at 0 and 1 and 1 and 6, and this was my graph. Now it's moved up. So the new asymptote is at y equal to 4, and the points will be, this point will be moved up 4. This one also will be moved up 4. So this is my graph. The domain is -infinity to infinity, and the range will be from 4 to infinity. Let's work on question 18 here. We want to graph log of x base 5. So if I have log of x base 5, let's see, if x is equal to 1, then we'll have log of 1 base 5, and we know that that's equal to 0 because 5 to the power of 0 is equal to 1. So one of the points is at 1 and 0. Then what if I set the x equal to 5? I will have log of 5 base 5, and 5 to the power 1 is equal to 5. So the other point is 5 and 1. These two are the two main points of any log function. So you always set the x equal to 1 and then set the x equal to the base. So it's going to give you two solid numbers or two solid points of the function. And we're going to graph the 1 and 0 is one of them. The other one is 5 and 1. And we know that the parent function looks like this, and the asymptote is here at x equal to 0. This is my asymptote. It's a vertical asymptote. The horizontal intercept, that means x-intercept, where the graph is crossing the x-axis, that's here. So it's at 1 and 0. The range from bottom to top, we see that the function is going to continue forever. So it's going to cover everything, all the y values. So it's negative infinity to infinity. And domain, you go from left to the right. And we see that the function is just starting from 0 because we have an asymptote. So you put parenthesis 0 and goes to infinity. And actually, I noticed that here I was supposed to graph x log of x base 4, but I graphed log of x base 5. I graphed the same thing that I saw on the top, which is okay. Just it's going to be the same rule, basically. However, if you want to graph log of x base 4, you can plug in x equal to 1, and you will have 4 to the power, you're going to have a y value equal to 0. So log of 1 base 4 is equal to 0. So 1 point is 1 and 0. Then you can plug in x equal to 4. So you will have log of 4 base 4, which is 1. So the other point will be 4 and 1. And if you want to graph it, you're going to cross 1 and 0 and 4 and 1. And again, it's going to be the same thing, the same rule. It's hard for me to graph, but it's going to look like this. And your asymptote will be still the same. Okay. Let's go to the next question. This time is asking us to graph log of x plus 1 base 3 here. So the parent function of this given function, it will be log of x base 3. So I'm going to find the two main points. When x is equal to 1, we'll have log of 1 base 3, which is 0. So one point is 1 and 0. The other one, x is equal to 3, you will have log of 3 base 3, and it's equal to 1. So I have 3 and 1. The same way that I talked in the previous one, once you set the x equal to 1, next time you set the x equal to the base, so you will get to main points of the graph. So if I graph them, 1 and 0 is here, 3 and 1 is here, and your function will look like this. This is the parent function. And there's an asymptote here at x equal to 0. But now what is happening here? This is moving the function left 1 because I have x plus 1. So left 1. So everything will be moved 1 to the left. The asymptote will be now at x equal to negative 1. And these 2 points will move 1 to the left. 1 and 0 will be at 0 and 0. 3 and 1 will be at 2 and 1. And this will be the graph of your function. Okay, so this was the first part of the video. The next part is about application problems, and I will make a second video over this application problem for you.